Hello, everyone. Welcome to another episode of Exploring 3D Experience Works. Wherever you are today, whether it's morning, evening, or afternoon, we thank you all for joining. And we have a very special session for you because today we actually have our very first special guest. So the other two sessions prior to this, it was just Gian and I having some fun.
That it was.
But now we've invited a special guest, Jordan Tadić, to have some fun as well with us. The name of today's session is Getting Flexible with 3D Sculptor. And there's Jordan himself right on screen. But before we jump into exactly what we'll be covering today, if you are new to this session, you might have a couple questions. Primarily, what is 3D Experience Works? Well, it's our growing portfolio of tools handpicked by SolidWorks to solve just about any design challenge you face. And of course, this is from design and engineering, governance, simulation, manufacturing, you name it. This is 3D Experience Works. So what does that look like in the overall design process or development process? Well, in its simplest form, we have three stages, right? We got planning, develop, and release. And well, we know that second step is tackled really nicely well by SolidWorks, and that's why we're going to kind of get into the design domain with some SolidWorks, not necessarily SolidWorks Desktop, but 3D Sculptor, which is a fully cloud-based sub-D modeling tool. So before I hand it over to Gian to explain exactly what we're going to be covering today, if you have any questions in the chat or if you just want to say hi, we'd love to hear from you. And with that, Gian, what are we going to be covering today?
Yeah, well, like you said, John, 3D Sculptor is the name of the game today. And if you remember, if you were with us back in January, we did our first session on January 28th where we were working on a pair of hair trimmers or beard trimmer, whatever it is to you, whatever hair you cut with it. And we took these internal components from 3D Experience SolidWorks that we designed. John was working on more the mechanical side, and then I brought it into 3D Sculptor to design this ergonomic and aesthetic enclosure for it using those sub-D capabilities. And then using 3D Sculptor, we brought that to life. But this was only part of an hour-long demonstration, and we didn't really get to do a really deep dive of 3D Sculptor. So that's why we asked Jordan, the 3D Sculptor expert here, to come join us and show us the ropes. And I think today could maybe even be like almost a training session for some of our folks here that actually use 3D Sculptor or are interested, right?
That's right. Yeah. Thanks for having me first off. And thanks for inviting me to show 3D Sculptor too, which is one of my favorite apps on the 3D Experience platform. It's super fun to use. My background goes into surface modeling. I've been doing that for 12, 13, 14 years. And I've always been the guy that like everyone sends like the really difficult models to figure out.
Curse
I always
knowledge.
like the challenge. But this 3D Sculptor has like helped me solve so many issues so much faster, so much more intuitively. There's still a place for surface modeling. I do it all the time. And there's a place for sub-D modeling and surface modeling to like hybrid modeling approaches. So when we're talking about 3D Sculptor today, know that it's not like the solution for all things, though it is a solution for a lot. It's really a great complement to SolidWorks surfacing tools as well. We'll get into some of the differences today. But yeah, you're right. This could be a kind of like a training course because I'm going to share as many tips on the user interface, keyboard shortcuts, all kinds of things we'll be covering today.
Great. So Jordan, why don't you go ahead and share your screen so we can take a look at what you're working on.
Excellent. Yeah. So this actually comes from a real life project that I've been working on recently. It started, well, I can't say last year. That has passed already, 3D Experience World 21. It was at 3D Experience World 2020 that we had a hackathon to redesign what was called the LN4 prosthetic hand. And this is something that, if you look at it on screen, this is a new version of it that we're working on. And but the previous version, they've distributed over 50,000 prosthetic hands to over 80 countries for free. So it's an amazing cause. It's filled with a ton of really, really kind people and generous people and volunteers worldwide distributing these prosthetic hands. So we are currently working on the redesign. Our team won that little hackathon, and now we're maybe like about a year away from actually mass producing the second version of this. So what I want to show you today is how we got started on this design. So let's jump right into 3D Sculptor and get started. What do you say?
Yeah, let's do it. Oh, it looks like people are happy to see you here, Jordan. Just wanted to mention that. Yeah, we got Ray Folks. Just wanted to give you a shout out and say hi.
Oh, hey, what's up, Ray? Glad you could join us today. Yeah, I hope a lot of friends from the SolidWorks community are logging in today, because this is as they know, my favorite topic. So, John, in your last episode, you mentioned like the start shape. I just want to point out we have a lot of variations here. You're starting with a digital hunk of clay. You can basically get a head start with it in a specific shape, starting shape. And but what I choose, the most versatile shapes are right at the top of the list, the box and the quad ball. So if you're ever wondering where to start with one of those two. And there's no shape that you won't be able to make with either one of them. And then the next thing that we're doing is we're just scaling to the approximate size. So we're going to be creating the finger here. That's what we're getting started with. And we needed to figure out what the average size was. So we're going like 100 by 20 by 20 right now. The next thing that you're prompted with is why we call this subdivisional modeling. How many subdivisions do you want on the model? So you see those 3 vertical lines going down the length of the model. But you see in the dialog box that's circled, I've only selected 2. So what that actually is representing is the columns of faces that you want along that singular face of the model or side of the model. And in this case, I know that I want symmetry down the center of the finger from right to left. So I want to place a line where my symmetry line is eventually going to be, and that's just going to make the model update a lot more predictably when I add that. Now for the side of the finger, I don't need it to be symmetric from front to back, because we're going to have the knuckle on one side, the little crease on the front. So I'm just going to choose 1 column of faces, which gives me a nice round radius on the side. And then for the length of the finger, I'm going to choose 10. And you don't have to get this right on the first try, because you could always insert loops after the fact, or you could delete loops if you've added too many. I always relate it to sketching splines. If you've ever sketched a spline in SolidWorks, you know that you don't want too many points, because then there's like just too much to control, but you don't want too few, because you need the level of detail that you need. So here I'm choosing 10 because if we look at the finger, the first stitch is kind of like a 3-point arc, right? So you got a point up here, a point in the middle, and a point at the bottom. That would leave you with 2 faces if we extend that out into 3D. And then the little crevice right here, another inverted, much smaller 3-point arc. So another 2 faces. So if there's 2 faces for each arc, there's 2, 4, 6, 8, 10. That's how I came about choosing this. Again, you don't have to put that much thought into it, because you could always insert loops or delete loops on the fly. And Gian, you showed last time, adding symmetry to your design.
Right.
And already, in just like the month that it's passed between those sessions, we've added enhancements. Now I'm going to show you a couple of them today. Now, just like SolidWorks, one of the best things about the SolidWorks user interface is that the context toolbar is always popping up, recommending, based on what you selected, the next step that you might consider in the modeling process. And here, if we select on a plane, it says, hey, do you want to make it symmetrical about that plane? And I do. So it will automatically choose that plane and start up the symmetry command, which is that green line going right down the center of our model. Now, I need to scrunch down the little wrinkle sections. And you always got to pay attention. The robot, the manipulator on the screen, is going to center itself to what you select. So I can't do them both at the same time. I have to do them individually. That will center the robot at the center of that little wrinkle. And then I could scale those entities down step by step. So just keep that in mind. Another keyboard shortcut is if I want to select an entire loop of entities, just double-clicking an edge will do that. So I actually wish we had that one in SolidWorks. Double-clicking an edge selects an entire loop of entities.
That'd be nice.
It's pretty convenient.
Yeah.
So from this front view, I'll taper off or round off the tip of the finger. And then my next step is to go to another view and make it look more accurate from that view. So double clicking those edges, I can translate the little wrinkle in the finger backwards, but the knuckles kind of look awkward, right? They're too sharp. So I could window select that, scale it outwards to soften the radius. And this is just the basic stuff I know that you had already covered with the previous episode, but now we could get into some kind of cooler things. It's starting to look like a finger, but
A little
it
bit.
also kind of looks like a deformed hot dog, kind of. There's not enough shape in this to make it actually look lifelike, right? So we need to add some more detail. But before I do that, I want the bottom of the finger to be perfectly flat, just so that I can have a flat surface for integrating with the rest of the design. So I'm going to select crease edges. And with the crease edges, you don't have to select just the edges to crease. You can select a face, and that's like a shortcut for selecting the 4 faces that surround that. Or in this case, because we have symmetry on, it's like selecting the 6 faces that surround that entire loop and creasing them all at once. So a good shortcut there. Now I'm purposely bringing this out of alignment because even though you showed this last time, just as a quick reminder, I wanted to bring up what the align by line feature does. So if I select all those entities that are misaligned at the bottom of my design, from the context toolbar, select align by line, I can then align them by line so that it flattens that whole surface perfectly. Like I could start a sketch on it if I wanted to. But I could also translate and scale as well. So we'll see that better here with this particular example, where what I want to do is I just want to taper the finger inwards a little bit, because obviously the finger starts off thicker at the base and then gets narrower towards the top. And I think that's a detail we were missing out on. So if I align by line with the side profile, I can then, it kind of looks like Yosemite Sam just got his thumb smashed by something that was swelling up. We could taper it inwards. That's the look that we're going for. And get what we're looking for. So I want to do that same thing from the side view here, but that just ruined the wrinkles that I took the time to create, right? So we have to remember, though the align by line is really convenient for translating and scaling the length of things, a whole sequence of entities, it also aligns them to a line, which might not always be desirable. So what we're going to do is introduce what's called the flex tool. So let me undo that really quick. And this is kind of where we got the name for the episode, right? Like we're going to show the flex tool, the bend tool. We're going to be twisting models all over the place. I think I threw out the first name like flex, bend, twist, ... yoga for modeling,
Yeah,
or gymnastics for modeling, or whatever it was,
Yeah, I thought we just said that because Jordan's coming on here to flex his 3D sculptor skills on us.
Yeah, exactly.
Oh, Jordan, we just had a funny comment in the chat, actually. I got to interrupt you. Jeremy decided to let us know he always avoids those hot dogs and the rollers at 7-Eleven. But I have a feeling, people who actually avoid them don't need to tell us that.
Yeah.
I'm a little skeptical.
Well, it's a good thing this won't look like a hot dog when it's finished, right, Jordan? I mean, at least that's what I hope, right?
That's right. We're getting away from that. But yes, life lessons from Jeremy are very important to bring up during these episodes too. You're going to learn about sub-D modeling and what to eat and not to eat at your local convenience stores. I appreciate that. So let's talk about the flex command. I'll try to figure out how I can relate some of these future features to convenience store tips, just to keep the theme going throughout. But the flex command is going to take some explaining so you can really understand what's happening here. So what you see here is a vertical line. I'm dragging that off center on purpose right now in the robot. The vertical line that I'm dragging into place is defining the range of influence of the tool. So maybe if I just wanted to bend or like flex the top portion, I could shrink the length of that line. But I want this to go across the entire length of the finger. And then you'll also notice that the robot has a little line connecting itself to the top. to just tell you that that's where the robot is. And by robot, I mean the little manipulator, the triad thing on there. And that is where the main influence is going to be applied. And then progressively from the top down to the bottom, that is the influence is going to get less and less. So it's like a tapered effect. Enough explaining. Let's just see this in action so you can see what I'm exactly talking about. I'm going to select all the entities on the side of this finger, and I'm going to drag the robot, and you can see how it influences up at the top more than the bottom. The bottom kind of stays static, and now we could add that tapered effect. So if I were to name this tool, as much as I like the flex name, I would call it the taper tool, because that's really what we're doing in most cases. Now, what if I wanted to drag the bottom outwards while keeping the top at the width that it was? I could just flip the side that the robot is attached to while maintaining that selection and drag outwards to taper the bottom outwards. So you could do this for the opposite side, the same effect. And again, it's like these small details that we realize when designing this prosthetic hand, that like it's the slightest details that differentiate like a mechanical, robotic looking finger to a lifelike one. And from the top view, we still have a ways to go because it's very much like a squarish profile. So what I'm going to do is I'm going to show what's called the cage surrounding this geometry. And anytime I want to get a better understanding of why is the shape, the surface looking like it's looking, I show the cage because that's like the underlying, it's exposing the underlying math behind the shape of the 3D model. Now, if you've ever sketched a spline in SolidWorks, you'll understand this pretty well because the new style spline that we added a handful of years ago is the absolute easiest and most efficient and highest quality way to sketch a spline in SolidWorks because you're doing it with construction lines and it's best fitting a spline through those. Makes it easy to parametrically define with dimensions and sketch relations. But here I'm just bringing it up because it kind of gives you an understanding of what the cage is doing. So what a 2D style spline is to a 2D sketch, the cage is to this entire 3D surface. It's like 1,000 style splines surrounding the model and transposing the entire model. And you can tweak any one of these cage points just like you could tweak a style spline to influence the shape in that particular region. So I've selected the entire edge of this design. And if I wanted to flatten out that curvature a little bit, all I do is pick the corner of those two construction lines and push them inwards to flatten out that radius. So that's exactly what I'm going to do with this model is just grab onto my robot. And you can see that the style spline or the the cage around the geometry would also very easily indicate to you if there's ever an inflection point in your curvature, especially like an unwanted one. At the end of my design process, I always turn the cage on just to make sure everything's looking right and that I don't have like a concave versus convex scenario going on with my cage unexpectedly, and I can correct that after the fact. Now, this is kind of a funky looking made-up scenario, but just to point something else out. And this isn't the best example that I chose here because we're doing this from the side view. And if you're working from an orthogonal view, like a side, front, or top planes, then just use a line by line in this scenario. But it's when you're working at a weird angle and you want a series of entities to be aligned in a theoretical line connecting from between the 2 points and everything else to fall within that line, then you're going to want to use this scenario that I'm showing right here. And that is what you want to do is you want to pick the 2 points first that are going to define that theoretical line. And then you can control select the rest of the geometry, whether by box selecting or individually selecting. And on the context menu, you'll get the option to align vertices to each other. And if we're doing that, what it does is it looks at the first 2 selected points, creates a theoretical line, and flattens everything to that line, which is super easy way to, take those times when the cage is just like inverted and you want it to be perfectly flat. You can pick those points and flatten it out very, very easily. Now,
so Jordan, I just had a question for you. I'm wondering how precise really is this stuff though? Like, can it compare to traditional surface modeling where everything is parametrically defined?
That is a great question. And actually, when I demonstrate this software sometimes to some of our clients, what they'll say is like, oh, it's really cool. It looks a lot of fun, but hey, we design for manufacturing and we need specific draft angles and we need this thing to be, to the 8th decimal place of precision so that we could, we could then send it to our machine shop, have it CNC machined and all that stuff and a mold designed off of this. And what I say to them is like, okay, this is still great in the conceptual phase though, when you're, going through the ideation phase and quickly generating ideas. You could always use it conceptually to make a design. And then if you wanted to, you could redesign everything from scratch inside of a parametric modeler like SolidWorks. But that's not even necessary because this tool does have a ton of very precise alignment features. The align by line, for one, is a way to ensure like perfect tangency or curvature continuity across a mirror plane and no inflection points across a draft or parting line. You could do all kinds of things like that, but I'll show you a few more. And in this case, I want the bottom surface to be perfectly aligned to the top plane. All right, that's where it needs to be, exactly there. Well, I can first, enable the selection of that plane. And then I could go ahead and select that plane as well as the surfaces. And from that context toolbar, I can align to geometry. And what this is going to do is exactly what I said. It makes that a perfect alignment to that top plane. So that is how we can ensure that something is, faces are perfectly aligned.
Wow.
But what about the size as well? You mentioned like dimensionally or parametrically controlling something.
Right. Yeah, how are you going to do that?
In this case, we could turn on the bounding box. And the bounding box is cool because it shows a live measurement of the total height, width, and depth of the model. And I could tweak the model and those measurements would update live. But even better than that, I could click on any one of those dimensions and then from the context toolbar, activate the scale command, which then allows me to non-uniformly, if I choose, enter in a precise value for each one of those dimensions. So 22 by 22 by 100. Again, we had to figure out what the average size was across all the genders, across all the age groups and things like that. And that was our baseline for this design. So that's what we figured out, and that's what we input for this part of the design to make sure it was precisely the perfect starting point. Now, I just showed the palm of this model, and I realized the finger's in the completely wrong location, so I have to move the whole thing. So a keyboard shortcut to be aware of is Control-A. It selects the entire geometry, and now I can translate all those points together at once. But again, let's talk about precision here, right? So I could drag it up, and I could snap to the ruler that pops up on the screen, but sometimes the increments on that thing is like every 1 millimeter, every half millimeter, every 5 millimeters. It might not be the precision that you want on the ruler because it's all dependent on your zoom level. So here's a workaround for that. So you can type in the exact numerical value that you want. Select the geometry, click an arrow, just a single click on one of the arrowheads of the robot manipulator, and then click the 0 on the ruler that pops up, just a single click. And that 0 is going to turn into a numeric input field that I could key in any value to whatever decimal place value that I need to. And then I could try and translate that to the side and see it totally doesn't work with symmetry on.
Oh, that
so
makes
don't
sense.
forget about that. We got to turn symmetry off. But I can see when I'm translating it to the side, it's about 28 millimeters. So I click it again. And this time I type in negative 28 millimeters because I know to type in negative because when the robot pops up, if the arrow's pointing this way and I want to move in this direction, I'll just type in the negative value of it. Now, when I'm scoping out the model, checking the progress, I like to hide the tangent edges so that the model is going to look more like it would in real life. And I could see how the light's reflecting off of it. And now it's time. I think we've got like a decent looking finger at this point. Let's talk about creating the other fingers, the other 4 fingers on the palm of this hand. So that is where I'm going to introduce ordered geometrical sets. It's a mouthful, but for anyone that's used SolidWorks before, it's also a mind-blowing enhancement that it's just the opportunities of workflows that you can accomplish with these ordered geometrical sets can get really, really creative and very, very cool. So for now, just think of it as a folder. I'm using it in its most simplistic workflow. And I'm creating multiple folders. And the reason I am is because I'm going to create a folder for each finger. And then that way I could keep each subdivisional surface of that finger separated into those folders just for organization purposes. And what I'm going to do is I'm going to take that first one that I created as an example, copy it, and paste it into those other folders. So we could copy and duplicate these files many times as we want and tweak them each time as well. So I could paste it into that second order geometrical set. And at this point, I could double click it to edit it. And I want it perfectly centered on the plane. So what I'm going to do is I'm going to select that plane. And also on the context toolbar now is a center on command. So that bounding box that we showed, it's creating that in the background and it's dividing it by 2 and moving it so that it's perfectly centered on the plane that you've selected. And you could essentially do this for the front, top, and right plane and have it right on the origin as far as you need it to be. Now I'll duplicate that one, move it 28 millimeters over to the right to be on the opposite edge of the palm. And then I'll create one more duplicated copy of this so that I can create the ring finger to go between the middle and the pinky finger. I moved the other one 28, so I obviously have to move this one 14 to center it up. So that's why those parametric numerical inputs are really useful. Now the gap, we wanted a gap between the index and the middle finger, but not that big. So I'm shifting this one over 5, which means I need to shift the other one over 2.5. But notice that we still see the pinky finger while I'm making these edits. And that is a big deal here with the ordered geometrical sets. What it does is you could create a whole string of parametric features inside of one folder, and they would all be time dependent to one another. But the ordered geometrical sets are not time dependent to one another. So that means if I'm editing something in an ordered geometrical set at the top of my design tree, and then if I'm doing some editing up there, I could still see all the other ordered geometrical sets that were created downstream. So it's kind of like a in-context assembly design mode without the burden of creating a bunch of separate parts and giving them part names and dealing with the data management stuff. So for conceptual design, this is also a great way to make multiple variations. All right. The final thing that I want to show here is the arc bend. This might be the most fun tool to use on the platform. So what it does is, if you notice, no one's hand at rest is perfectly flat. It's always kind of curved a little bit. And that's what we want to do here. So just like the flex tool, it has a vertical line. You can make it horizontal depending on how you're orienting it to your model. But that vertical line in this case is also defining the range of the bend. So again, if I tighten it up, it's going to have a tighter radius of curvature. If I lengthen it, it's going to have a more sweeping radius across the length of this finger. And then you just drag the arc and bend these entities around. So let's see what that looks like. And that makes me flinch a little bit. That reminds me of some like basketball injuries I've gotten on the court back in the day. Like,
those are the worst.
Hyperextending the finger bend.
Oh yeah.
But yeah, you could see how easy it is to push and pull these things around. If we had to do that for each individual loop, I would have had to translate, rotate, select the next one, translate, rotate, and it would have taken forever. But with these advanced tools, it makes those complicated translations super, super easy. So what do you guys think so far? I mean, there's still work to be done with this one, but those were the tips that I wanted to show on this particular example.
Totally, yeah.
I'm really personally just amazed at like how accurate it can be. I mean, even Jeremy Regneris in the chat, he said, we're able to machine this using the shop floor programmer with an exclamation point. So, I mean, I'm really, really amazed at like, it's not just about making shapes, but it's about making precision as well. So that's pretty cool. But we do have like, the chat pretty much blew up, Jordan. I mean, you did a great job in the time. But I think there's a little bit of confusion around, is 3D Sculptor part of SolidWorks, or is it a new program? And then maybe you guys could also touch on how it could be available to SolidWorks users and what they'd have to do, some of the options that they have.
Yeah, well, maybe I'll answer the first question, then you could answer the second one, Gian.
Sure.
The first question is it a new application? Yes, it is. It's, like John mentioned at the beginning of the show, it's part of the 3D Experience Works portfolio. Did we even mention we're working on the cloud? We're working within a web browser. Yeah. I have that part of the screen cropped right now, but I'm telling you, every time I design it, I forget that I'm working on a web browser because the performance is excellent. We're continually improving it. Like just this recent release has like all these even higher definition, higher quality visual renderings, live visual renderings of the model and appearances. Cool. It's just, it's off the hook, like how good it is on the cloud. And but it is a separate role. So if you have SolidWorks today, it's not like this comes for free with it, but there are some newer versions of SolidWorks coming out, and that are out, I should say. And maybe John, you wanna mention that a little bit?
Yeah, totally. So right now, one of the newer versions of SolidWorks we have 3D Experience SolidWorks that is connected to the 3D Experience platform, but it's the same SolidWorks you know and love. And if you get professional or premium of those, you actually already have 3D Sculptor. But if you have SolidWorks Desktop already right now, there is a collaborative designer for SolidWorks for connecting your existing SolidWorks to the cloud. But 3D Sculptor actually includes those capabilities. So you can just buy 3D Sculptor to go with your desktop SolidWorks.
Exactly. Yeah. And it's pretty affordable. So it's, if I was doing product design and I'm big into, especially if I'm doing any kind of surface modeling, like I'm going to want this as a tool in my toolkit for sure. Because like I said, actually the next example that I'm showing, Gian, is going to include kind of like a hybrid modeling approach that will kind of illustrate that.
Yeah, actually, I got a prompt for the chat right now. If you're watching right now and you have a specific question about a workflow or something that you particularly would want to try with this, leave us a note or leave us a comment, and we'll see if we can include it in one of our future sessions.
Yeah, I love modeling challenges, so
we'll have to bring Jordan back.
That would be fun.
Totally.
Yeah. Oh, Jordan's definitely gonna have to come back. No.
Oh yeah.
We'll see. We'll see how the crowd reacts by the end of the episode. Who knows?
Yeah.
The verdict's still out.
But Jordan,
well, I don't foresee things taking a turn for the worse, but I guess we'll get back to Jordan and we'll find out for ourselves, won't we?
Yeah, I'm curious. What's next on the agenda, Jordan?
So next on the agenda for the LN4 project, I should say, is we're planning to have this thing continue on this design. The next step in this design process was, we had this basic shape. Then I invited in a group of people. I was running 3D Sculptor, and they were all watching, but they were all weighing in their opinions, like, tighten up that knuckle or round off the fingertips to make it easier to touch a touch screen or a cell phone. And I was doing all those edits live. And that was one of the most gratifying thing about 3D Sculptor is you don't have to wait for a feature tree to rebuild. Like anything that someone mentions during a design review, you could implement it immediately and get that instant feedback if you're headed in the right direction. That is one of the coolest things about this, which is why, especially if I was doing new product design, like in a conceptual environment, this is an absolute must.
Totally.
So we're trekking on. We're bringing this into X design. We're shelling it out. We're adding ribs, and we're at the point where we're dealing with like the mechanics of it, the ratcheting mechanism, the bringing back in the linkages that we conceptualized during the hackathon. So we've got a long way to go still, but we made a lot more progress than I just showed you in these few minutes. So the next design, which is what your actual question was, is this DTV shredder, and this thing is a beast. It's like an off-road scooter, but that's not the right way to describe it.
No.
Scooter sounds like way too.
Yeah, way more
this
hardcore.
Thing is, Yeah, exactly. This thing allows you to kind of like surf across mountains, basically. With the DTV stands for dual tracked vehicle, I believe. And thank you to Mike Sandy, our colleague, for creating this beautiful rendering. I believe in Visualize Connected, which connects to the cloud, the 3D Experience platform as well. So what we're going to be focusing on, though, is the board that you actually stand on. So I created this entire thing I can't say that. I didn't create this entire thing in 3D Sculptor. It took another app, and we'll expose that when the time comes. But one of the challenges with this one is that I had to make sure that it fit perfectly in context of the design. So there's a couple of mounting brackets in the assembly that I needed to blend the bottom of this board too. So let's get started. This is the context of the assembly. This assembly was designed in SolidWorks, and you could just bring that right into 3D Sculptor, no problem. But this time, instead of starting with a solid chunk of clay, digital clay, right, we're starting with like a piece of cardboard. A surface is what we're starting with here. And that's because, uniformly, for the most part, this board is a thin, design. And when I'm picking subdivisions again, my mind is going to like, hey, I'm going to make this symmetrical, so I want an even number of subdivisions. So I have a bisecting line down the top plane and the side plane that I could provoke symmetry around at any. Let's turn that symmetry on. And then we need to round the one end of this board. So a quick way to do that is with the subdivide faces, because what the subdivision tool does is it will take the faces that you've selected and surround them with another loop of faces. And this is a great way to add more control points in a localized area. So if I want a little more detail in this area, then I subdivide the faces. I get that many more vertices that I could push and pull around. That's a concept here. And I can extend surfaces. I can turn on the bounding box, right, to make sure that this is scaled to the exact dimensions that we need them to be, just like I did before. That's pretty much a part of every single one of my modeling workflows anymore, because size, is important. So in this particular case, so remember we showed the align by line tool previously, and that's what we got with a flat surface. But I do not want this to be a flat board design. I want this to have curvature. I want it to be misaligned, right? So the opposite of that is quick align by curve, all right? And what this allows you to do on a pen tablet or a touch screen, you could just freehand sketch a curve across the length of your model, and it will, like a magnet line, just kind of like suck all those vertices down to fit that contour. That is way faster than individually dragging each one of those vertices into place again. And with this workflow, the thing that I like about it, especially with my background in surface modeling, in surface modeling, what we're doing is we're building. The difference between surface modeling and solid modeling is solid modeling, you start with like all 6 sides of a cube right from the get-go, right? And you start already fully solid. Whereas surfacing provides you flexibility, because you could build a little piece here, you could build a little piece here, and you might not know where this other piece is, so you could get to that later, but then you could start blending the pieces together, and you're just like growing your model as it comes together. And that provides for really, really flexible workflows. In this case, we could do the exact same thing. So here I need some additional material coming off of these selected edges. So I'm going to pick the extrude tool, and that adds additional geometry. It's like the extend surface command kind of, and you're just extending it outwards. And here is, the other part of surface modeling is blending surfaces together. Typically what we do in SolidWorks is a boundary surface, and then we got to worry about, all right, what's the boundary constraint over here on this side, and what's the boundary constraint over here on this side, and can we really make a curvature continuous, or do we have to revert back to tangent boundary condition or something like that to make it work? Here, everything by default is curvature continuous, and I could just merge those open edges together to patch that gap. As simple as that. And everything has a C2 level of curvature continuity. it couldn't be easier. So if anyone has surface modeled on this call today, they're just like, they might be drooling right now because of how simple this workflow actually is. And then I can make sure that that additional loop that I added matches the curvature of the frame underneath for the aesthetic value, and also aesthetically open up these little vents or these gaps in the board. It looks cool, but someone might get their toes stuck in there. It might not be the safest thing, but again, I'm just going for style right now.
Yeah, out of our jurisdiction here.
Maybe one thing for functionality is like I'll extend the flat area so that someone's full size foot could fit on the board and it's not all curved or too curvy. But just like that, I've got, a main portion of the board design, the top surface. And that if I wasn't yapping so much, that could have been done in just like a few minutes, right?
Yeah.
So
no,
the next step, well, what would you do next, Gian?
I'd just thicken this. I mean, unless you have something else crazy planned, yeah, I would just add a nice uniform thickness to this whole thing.
Totally, yeah. That could, if that's all you needed. If this was a skateboard, yeah, because then you mount like the trucks onto the bottom of it, and you're done. Wow, I never thought about that, like 3D printing a skateboard. How long would that last? Like a couple ollies, maybe. But or anyways, what I'm going to do here is something a little different because I don't want this to be a uniform thickness. I actually want the bottom to be a different shape because remember, we got to mount to the mounting pads on the actual assembly.
Right.
So what I'm going to do instead is I'm going to copy that original sub-D body. I'm going to paste it to make a duplicate copy of it. And I'll hide the original one and then edit the second one. And I need this to be down, like a thicken command, 7.5 millimeters about. Okay, so I'm going to move that down in the negative 7.5 millimeter direction. And then what I'm going to do is I'm going to select these two faces to crease the surrounding edges of the faces. And that would give me a nice sharp edge that I could then move to match up with the mounting pads. And typically what I do in the past is I would kind of like drag this down, scale, eyeball. We could use that align to plane tool that I showed you earlier, but I'd still have to kind of like resize things. Now what we could do is we can align a curve or a loop of edges on the sub-D model to, in this case, I just have a reference sketch down on the mounting pad, the top surface of the mounting pad, or we could use model edges as well. And we can align those two curves to one another. And it doesn't get easier than that. It actually does. If I added fillets to that sketch, then I'd only have to select one edge of the sketch on the bottom. And I should have done that to speed up this demonstration. But I didn't even realize it at the time because there's a tangent propagation checkbox in this alignment tool that would automatically loop around and select all the edges of that sketch.
Hey, Jordan. So Jeremy says if you get your toes stuck in that board, you're going to need to model toes instead of fingers. So
some broken toes, maybe.
Yeah, actually, it starts off wide and it gets narrower and narrower. Like it'll just like chop them off. Moving.
Oh.
Hopefully, no one's wearing sandals when they're riding this thing. Steel toe boots would be necessary.
Steel toe, yeah. Good old steel toe.
All right, so anytime I want to figure out what is going on with the model, remember I show the cage. So in this case, you might be wondering, like, it's kind of like a circular shape down at the bottom, but the bracket that you have is square. And that could be explained because what we're actually doing is we're aligning the cage entities to that sketch geometry. And because I have the bottom edges creased, that bottom face is flat. But if I wanted it to be sharp corners so that it actually followed the shape of the square bracket, I would have to crease the vertical edges at those corners as well. Because essentially what the model is doing, remember with that style spline, it's always best fitting a nice curvature continuous spline in between those cage points. And unless I crease this corner that's going through here, then it's going to be a smooth transition. And that's what it's doing. It's just rounding it off. But if I were to crease this edge coming in the Z direction, it would suck those edges right to the cage extents, and that would give us a rectangular shape. All right. So kind of geeky background information there, but that really is what makes you truly understand what's happening in the subdivisional environment so that you can get really predictable results and play it to your advantage. Now, I have two surfaces, and I need to make this a solid model. So I need some additional features. This is one of the coolest things about all the cool X apps that we have on the 3D Experience platform is that I can hit the X key on my keyboard and swap over to any other one. Now you think like, oh, I have to shut down the model, I have to find it again, I have to reopen it. No, that's not the case. Just clicking any one of those other apps, all it does is it keeps the model right where it is, and then it shows you a new toolbar where now I could access the loft command. So firing up the loft command, this is going to be super simple because if I click one edge and another edge, the two originating surfaces that I'm referencing has the same amount of subdivisions. It knows to tangent propagate all the way around. All it takes to add a loft is just 2 clicks, selecting one edge from one profile and another edge from another, and it patches that gap just perfectly. Now we still have blue edges, which if you've surface modeled in SOLIDWORKS, you know is a open surface edge. So we need to knit those together to make them watertight. And if you have enough surfaces and there's no gaps at the end of this command, then you can also select the Make Solid checkbox on the Knit Surface command, which turns these groups of 5 surfaces here into a completely solid model. And again, I think this is a really cool workflow because not only did we use sub-D modeling, kind of like a surface modeling thing, we grew the model out, we merged things together, but we also used surface modeling features with it, the loft feature, the knit feature, the make solid option, and it all comes together. And if I were to edit either one of those sub-D models, all the downstream features would update very predictably. So there's like, as far as workflows go on the 3D Experience platform, like there are so many that you could do, just like merging all these apps and jumping between them and using all the different features they have to provide. Pretty cool stuff.
Totally. Yeah, very cool stuff. And that was, I mean, what was that? 2 sub-D surfaces and then 3 lofts and a combine. And that's what you ended up with. That's pretty outstanding.
That's a great point, because if we think about like how many surfaces that would have taken, how many features that would have taken in a traditional parametric surface modeling, like that would have been a heck of a lot more. Lots of sketches, lots of dimensions, all kinds of things. Whereas here, it's totally manufacturable. It's ready to go. We could introduce some draft angle in there if we wanted to, if it was necessary across that short edge face, but it's easy. So that's all I had to show today. But Gian, I want to put you to the test and see if you could take some of these new features that you've learned and maybe like reapply them to that old trimmer model. Because I think you could make that thing even cooler looking than you already have.
Yeah, that's a great idea. I'm feeling pretty inspired too. I think a lot of these I could use right away. But before we do that, I just want to check with John and see how we're doing in the chat. I saw one conversation.
Yeah.
Oh, sorry, go ahead.
Yeah, we got a lot of positive feedback. I mean, so much positive feedback, Jordan. I can't even read all of these throughout the entire presentation. Really cool.
So I might get invited back, you're saying. Awesome.
Yeah,
I think
that's a solid
pretty,
maybe.
a pretty likely scenario.
Solid
but
maybe.
I think, also now would be a good time to talk about, I'm sure you've really inspired a lot of people who maybe want to try it out. And Gian, I'm pretty sure it's available for a free trial for them. So maybe you want to talk a little about that. I know there's a link in the chat for the 3D Experience trial.
So there is a 3D Experience trial right now where you get to get your hands on 3D Creator and 3D Sculptor. It's not a very long trial, so right now it lasts for 14 days. But yeah, you can go and fill that out through the link in the chat, or if you just go to SolidWorks.com, it'll be one of the first things that you see on there. But yeah, Jordan, I mean, this chat, this chat's been all over the place. There was a conversation about bratwursts
Hot
versus
dogs.
hot dogs
Yeah.
before. I mean, I don't think you
How
can.
many brats you want for lunch, Jordan? I think somebody
Yeah.
asked
Yeah.
that.
I'll model them up. I'll model them up.
Yeah.
We just need to model a grill in X Design, which I think actually one of our coworkers, Sal Lama, did and shared that design just the other week
Oh, a whole
in a
grill?
post.
Wow. That's
Yeah.
pretty cool. We might have to steal that and show it on here sometime.
Yeah, it's really cool.
But
All right, Jordan. All right, Gian. Sorry, I'm itching to know. Well, how is this inspiration gonna play out?
yeah, let's see. So, all right. So we're all done with Jordan's shredder board right now from the DTV shredder. I'm gonna jump in, and I was actually working on the trimmer before, so just using my recent my recent components that I've been working on, and I think I'll just hide some of these internal components. And then
Yeah, let's not worry. Let's not trouble ourselves with those. Let's just get wild with this shape, Gian.
totally, yeah.
No.
In fact, I think
Mechanical design can deal with it
Yeah.
later, whatever changes.
they'll figure it out. They'll figure it out. But just to keep things a little bit clean, so we don't break things for what's existing here, I think I'm gonna make a new ordered geometric set like you did. But I'm gonna do it for a slightly different reason. I actually just want to copy and paste that same sub D body into this new order geometric set, just to play around with it and see what kind of changes I'm feeling at the time.
Yeah, that's a great idea. And that way you could preserve the original one while trying out a new idea. Obviously we could create branches and we could create revisions, but in the conceptual phase, especially with like a wild idea, you're not sure where it's going. This is a much faster way to do it. Just experiment really quick without ruining your previous model, right?
Right. Yeah, I think just so I don't mix the two up later, I'm gonna color this a different color.
Yeah. That way your boss isn't getting mad at you for making a tweak that was unapproved or something like that. Yeah.
Right.
Good idea.
Exactly. All right, so the first thing I didn't really like about this is I think that we need a little bit more beef. Need to beef this thing up in the bottom. It just gets a little too narrow for me. So I think a couple scale. Yeah, I'll scale this once, or I guess I should scale it again then.
Yeah, it's not too bad. A couple of clicks. It doesn't take that long, right?
Yeah.
But notice how like it's a teardrop shape. Like the bottom is much wider than the top.
Yeah,
I don't know if that's really what you're going for, but that's because of the successive scales. So I think this would actually be a great place to use the flex tool. Just like if you undo this and select all those geometries right from the get-go, or those vertices right from the get-go, and then use the flex tool, that might be even better.
All right, yeah, I'll give it a try. I think I gotta flip this the other way so I can scale the bottom, and then I think just those nodes and should do it.
Perfect.
And,
Yeah.
Oh yeah, that's much better.
Yeah. So that tapered effect allows you to maintain the overall taper of the design and not lose that design intent. Yeah.
Right.
Very nice.
Okay. The other thing I saw you do was that sketch curve, or a line to the sketch curve. All right.
Yes. You got to give this a try.
Totally.
It's fun.
Yeah, I wanted to try that on my parting line here, which might not even end up being my true parting line, but either way, it's like, the interface between two surfaces that I want to have a little more style than it does. And yeah, that's
nice.
That's pretty cool.
As simple as that. Yep.
Oh, it looks like it messed up that side over here, but I guess, yeah, the align by line should fix that then, right?
Totally. Yeah. Now that face is planar. You could start a sketch on it if you wanted to. Yeah,
Oh, wow.
for sure.
All right, so there's another couple things I wanted to try. Now I wanted to have like a loop on this thing so I can like hang it on a hook when I'm done. So I'm just gonna start extruding this thing, like these little blobs off the side, and then just try and turn that into a loop somehow.
Yeah. You're as it is right now. It's probably not hanging on any hook.
Yeah.
We know of, right?
Yep.
But and you can bring those closer together. kind of get there. But really what you could do is, because you're selecting opposing faces, remember when I merged those two surfaces together?
Yeah.
Like on the toolbar, there was a merge feature.
Right. Yeah.
And that appears in the surface mode when you're selecting edges. When you're dealing with 3D geometry and you have opposing faces, you can actually click the extrude feature on that context toolbar. And what it will do, rather than extruding those individually, since they're within a close enough vicinity of each other, it'll just blend right together. Hopefully. Give it a try.
Okay.
We'll see what
Yeah.
happens.
Yeah. Let's give this a try then. That extrude, you said? Yeah.
Yes.
Okay.
That'll do.
Yeah. It
Yeah.
looks like that did it. Ooh,
Yeah,
the
so it
surface.
might need some tweaking a little bit, but that accomplished what we were looking for.
Definitely.
Nice. And if you want to do some tweaking, like you could select all those faces and make them coplanar by making them coincident. And if you look at the other things on your toolbar right now, we can make edges collinear with one another.
Oh, yeah.
We can make them parallel, perpendicular. So there's more like parametric controls to quickly and precisely align all these edges and entities and vertices, you name it. And with faces selected, it'll just make those all averaged out onto the same plane. So give that a shot.
All right. Yeah. Yeah. Let's see how this looks.
That way you could get rid of the twist throughout. Yeah, perfect.
Oh, wow. Wow. That is like completely flat now. So
Yep.
I mean, that's just always better to have this like nice flat surface be my starting point, and I can add the curve where I want to, rather than the other way around.
Exactly. Yeah. Rather than trying to untwist that thing manually and level it all out, that would take way too long.
So Jordan, I heard something about X-Shape or about 3D Sculptor that extrude command can actually like punch a hole through a solid body too. Yeah.
Yes. Yeah. If you want to try it, I mean, I don't know if it would make much sense for this design, but if you pick opposing faces, like maybe on the side of
Yeah.
like right there, and the exact same one on the other side, hit extrude, and yeah, that's what happens.
Oh, that's pretty cool.
It's great for like creating handles, or like loops of that you need to add.
Yeah.
I don't know if it would work for the trimmer design, but
Oh, you don't like a
it
nice
looks
like a
cool to show.
vacuum
thick
cleaner.
grip to cut your hair? Yeah. It does look like one of those little handheld vacuum cleaners. That's cool how it kept the crease going along that edge too. That's very handy.
Yeah. It will. It takes the adjacent conditions and loops it around and just continues it on for the additional faces it creates. For sure. Yep. I don't know, John. What do you think? Should we keep it like this? I don't think so.
I think we should probably just, stay on task and maybe just make that hair trimmer. I don't know, but it's up to you guys, I guess.
No, that's cool. That's cool. Somebody's got to keep us in line here, or we'll be here all day messing around. All right, so I'll Control Z a couple times to get rid of that, and then I do want to try that arc bend. That just looks like such a cool tool to use. And oh wow, so it just snaps right to that arc. Wow, that's like very easy. And that I can't tell you how many times I've like wanted to do that, and it's been like a million clicks to like drag and then translate, rotate, back and forth.
Yeah.
But in this case, I think I'm just going to undo this because I want to keep things a little bit easy for our mechanical engineer.
You're way more considerate than me. I would have kept it like that. That looked cool. They would have had to like alter the whole drivetrain and the motor connections and all that stuff.
Yeah.
Whatever.
I like to be friends with my engineer, so that's.
Oh man, good for you. No, okay.
Well, I think the last thing, I could scale this whole thing by that one distance line right there, controlling, and I just drag and drop those points anywhere. But I'm totally gonna steal your bounding box trick here.
Yeah.
And just scale non-uniformly. Get some nice.
Make sure it's the exact size you need it to be.
Exactly.
And then maybe to wrap this up, what I always recommend is jumping over to the cage view and making your final tweaks there. Just so it's like a final visual quality check to make sure you don't have any strangely inverted surfaces or anything like that. So that'd be a great way to wrap up.
Yeah, let's do it. So I'll go to the cage view. Well, this is a cage with surface. I think it gets a little hard to see some of the points when they're inside the surface, so I'm just going to go full cage.
Oh, yeah, good idea. Yep.
And yeah, it doesn't look bad. There's definitely some areas I'd want to tweak though, because if it looks good in the cage, it's going to look great, with the real surface. But I could spend hours doing this, just doing like minor cleanup. So I'm just going to fast forward through a lot of this, just so we can get to the final product. And then when I turn that off, we can see so much smoother, much better transitions.
Yeah. Yeah, straight curves and loops through there just lead to really predictable geometry.
Yeah.
When we're getting into like draft analysis and things like that, much more predictable results and controllable results there to ensure it all looks good. And that edge you have selected right there, I was kind of on the fence with that one.
Yeah, I don't love it. It
kind of like twists down through the model.
Right.
But I'll tell you what you could do. You could just remove it. And normally you wouldn't think that you'd be able to do this, because if you think about it, you'd be going from a creased edge to a perfectly curvature continuous set of faces, right, all across like one point instantaneously. But give it a shot.
Well, all right.
Yeah.
All right.
Yeah.
All right, let's see it. So if I just hit the crease to get rid of that. Wow.
Oh, and I think my camera just went out. I apologize. I don't know why that happened. But that gives you the exactly what we were looking for. And again, think about what it would have taken in traditional parametric modeling environment to accomplish that. With all the boundary conditions and things like that.
Oh.
Going from a creased edge to curvature continuity across a single point, and it's awesome. It couldn't be any easier.
Yeah, that's just so impressive to be able to do that. I don't think I've touched a program that does that well before. But I'm just going to unhide some of those other components. Let's take a little look. Oh, great, you made it back.
I made it back. I'm sorry about that.
No worries, no worries. Hey, if that's the only technical difficulties we had this session, I'd call it a success.
That's right.
But yeah, this looks pretty good to me. So I think my manager's going to be pretty happy with this new concept. So I'm going to just wrap it up right there.
Perfect. Yeah, I love it. Great job.
Thanks. Yeah. Hey, it's easy when you got a good coach. So John, what's you want to close us out?
Yeah. Real quick, I know we're over time, so I really appreciate everybody for hanging out just a few extra minutes. If we didn't get to your questions, do apologize, but if you want to learn more, there is a link in the description. So special thanks to Sarah Zuckerman and Mark Peterson. These two were, the reason why the show went so well today, because, they're behind the scenes helping us connect with you. So we can't thank them enough. And so be sure to tune in next time, April 29th. And we're going to be covering a fully cloud-based design with 3D Creator, 3D Sculptor, and 3D Sheet Metal Creator. So until next time, thank you all so much for joining us. And thank you, Jordan, for joining us. Really appreciate it. And man, just a fantastic episode, I think. So I think everybody else enjoyed it too.
Yeah.
Well, thank you so much for having me. The pleasure was all mine. Take care, everyone. Stay safe.
Thanks again, everyone.
Bye.
See you next time.